Okay, hello everyone. Okay, so the next program in chapter 4 is Celsius to Fahrenheit table. So write a program that displays a table of Celsius temperatures 0 through 20 and their Fahrenheit equivalent. The formula for converting the temperature from Celsius to Fahrenheit is this. Okay, just space this out a little bit. Okay, so where F is Fahrenheit temperature and C is Celsius temperature, your program must use a loop to display the table. Okay, so basically what this program is going to do is it's going to use this formula to calculate the Fahrenheit temperature given the Celsius temperature. Now, it's going to create a table starting from a Celsius temperature of 0 all the way to 20. So it's going to first calculate the Fahrenheit temperature if the Celsius is 0, and then display the result. And then it's going to keep going. The Fahrenheit temperature if the Celsius temperature is 1, and then keep going. So it's going to basically insert the Celsius temperature of starting from 0 to 20 in this formula and display the Fahrenheit temperature equivalent of all of them. So we're going to have 20 Fahrenheit temperatures given 20 inputs, which is 0 all the way to 20. Okay, so yes. Okay, so all right, so let's start the program and then it'll make more sense. All right, so let's start. So I'm going to go ahead and create the class, and I'll call this Fahrenheit table. And I'll go ahead and create a main method. Oops. Okay, so for this program, we are not going to be accepting any input from the user, so we don't have to import anything. We can just start by even creating the loop. Okay, we can just start by creating the loop, and we will create more variables as we move on. So I'm going to create a for loop that is going to start from the Celsius temperature of 0. So I'm going to declare a variable. I'm going to say int. Let me just space this out a little bit here. Okay, so I'm going to declare a Celsius temperature variable, an integer Celsius temperature variable, and I'm going to initialize it to 0. So I'm starting a loop from 0, and as long as the Celsius temperature is less than 20, okay, as long as the Celsius temperature is less than 20, do what's in this loop, and before you come back up and check to see if the Celsius temperature is less than 20, go ahead and add 1 to the Celsius temperature. Okay, so you are starting from 0. We are starting from a Celsius temperature of 0. And as long as the Celsius temperature is less than 20, actually we want to include 22. So as long as it's less than or equal to 20, so I guess we'll have 21. I'm not sure. Yeah, we will have 20 instead of 20 inputs. We will have 21. I guess. All right, because we are including 0. We are including 0 and we are including 20. So I guess we'll have 21. Okay, so we are starting from a Celsius temperature of 0. As long as the Celsius temperature is less than or equal to 20, do what's in this loop, and before you come back up and check this condition to check or to see whether Celsius temperature is less than or equal to 20, add 1 to Celsius temperature. So basically what this loop is going to do is it's going to start from 0 and go around a couple of times, this number of times. So it's going to be actually 21 number of times because it's going to start from 0, 1, 2, all the way to 20. So it's going to go around 21 times, I guess. And it's going to do what's in this loop. Each time the loop comes back around to check the condition, Celsius temperature is going to increment or go up by 1. And as long as the Celsius temperature reaches 20, or is not less than or equal to 20, this loop is going to break, or is going to stop. It's going to be exited, so pretty much. All right, so in this loop, what we want to do is we want to go ahead and calculate the Fahrenheit temperature given or based on the Celsius temperature. So when the loop starts, Celsius temperature will be 0. So let's go ahead and calculate the Fahrenheit temperature for when Celsius temperature is 0, and then the loop is going to go up for 1, and the loop is going to go up for 2. Basically, let's calculate the Fahrenheit temperature given all the inputs of or given all the values of Celsius temperature as this loop is being executed or being run. So we are going to store the Fahrenheit temperature based on this calculation. So this is times. We are going to store the Fahrenheit is times. Okay, so we are going to store the Fahrenheit temperature based on this calculation in a variable we are going to create. We haven't created yet, so let's go ahead and create that variable. I'm going to go ahead and create a double variable because these are going to say because we can end up getting a decimal. Actually, we can have 56.5 degrees Fahrenheit. So that's why I'm creating a double variable. That double variable is going to be called Fahrenheit temperature, and it's going to hold the Fahrenheit temperature based on the results of this calculation in the loop. I'm also going to go ahead and actually that's it. I don't need a Celsius temperature because that's what's going to be stored in here. The Celsius temperature is what's going to be stored in here. And you know what? Instead of let's see. Instead of an integer, I'm going to also set Celsius temperature to double. Although we are checking from 0 to through 20. You can keep it as an integer. I'm just trying to keep all the values as a double, just so that but you can keep it as an integer because this calculation, let's see. Over here we'll encounter a problem, but we'll fix it. But I think for now a double makes sense. But if you keep this as an integer, it's fine. The only thing you have to do is you'd have to do some typecasting here to make sure that the result of this returns a double if it indeed evaluates to a double. So you'll understand once I get there. But for now, I'm going to declare it as a double because I want to keep all the values as doubles. And what I'm going to do is just basically create this formula here. I have the variable Fahrenheit temperature to hold the result, so I'm going to say Fahrenheit temperature. Let me just go ahead and copy it. So Fahrenheit temperature is going to be equal to now 9 divided by 5, so 9 divided by 5, and all of that is multiplied by the Celsius temperature. So I'm going to surround 9 divided by 5 parentheses, and all of that is multiplied by the Celsius temperature, which is C. C is the Celsius temperature, and I have the Celsius temperature stored in this variable as the loop is going on. As the loop is running, initially it's going to be 0, and it's going to loop all the way to 20. So I'm going to multiply by the Celsius temperature. Let me go ahead and copy that too. And then we are going to add 32 to the result. So I'm going to go ahead and surround all of this just to try to keep the order of operation, and add 32. So that's basically the formula that's going to calculate the Fahrenheit temperature when or based or depending on this Celsius temperature variable. Okay, so what we want to do is we want to create a table and then display this result when each time, like for example, if it's 0, when Celsius temperature is 0, when Celsius temperature is 1, and so on, all the way to 20. So first of all, let's go ahead and create a header for this display or this result output. So I'm going to go ahead and create a header. I'm going to use a system.out.println statement and display the results. So first I'm just going to type a header, which is going to be the Celsius temperature, and I'm going to create a tab, and I'm also going to, the next column is going to be the Fahrenheit temperature. Okay, so now I have a header at least. Okay, so the contents or the results are going to be displayed here. So each time you find a Fahrenheit temperature, let's go ahead and display it. So now we have the Fahrenheit temperature. So let's do this. Let's create another system.out.print statements. But because I want to format some of the results, because sometimes we might end up getting 56.00004. You know, we can end up getting lots of numbers with lots of decimal places. So we need to format it. So I'm going to use the system.out.printf method to format it when needed. Initially, I'm not going to format it just so that we see the raw result, and then later on I'll come back and format it. So the first thing I want to display is the Celsius. Let me even go ahead and underline this header. So once I create the Celsius temperature, I create a tab, I create the Fahrenheit temperature. I'm going to create a new line with a new line character. So it's going to move to the next line, and I'm going to underline the Celsius temperature with some dashes like this. And I'm going to go ahead and create another tab and underline the temperature with a couple of dashes too. And then it's going to move to the next line because of the system.out.println statement. And inside here, we want to go ahead and display the Celsius temperature. It's going to go under the Celsius temperature, which is going to be the variable Celsius temperature. Initially, it's going to be 0. It's going to be incremented by 1 each time, all the way to 20. So we want to display the Celsius temperature. Because it's printf, we want to format it, so we have to create format specifiers. Okay, so I'm sorry for my cough. I apologize. I have a slight cough, so please bear with me. Okay, so because we want to create a format specifier, the first thing I want to display is the Celsius temperature, and I have it here in this variable Celsius temperature. But for now, because of the printf statement, I'm going to create a format specifier, a placeholder with a format specifier, basically, or a placeholder with how you want it formatted, how you want that value that's going to replace the placeholder formatted. So I want Celsius temperature, first of all, displayed as a float. Okay, so let's initially display it as a float. So %f, and I'm going to go ahead. So this is a placeholder. Something is going to replace it. Just a second. So I'm going to go ahead and create a tab, and the next thing, a tab is the \t is like a tab, just like what we did here. Okay, it's a tab. And the next thing I want to display is now the Fahrenheit temperature, which we have here. So we're going to display it each time the loop runs, or the loop iterates. So the Fahrenheit temperature, I also want to display that as a float. So I'm going to create a %f to signify that I want to display that as a float. And what is going to replace these placeholders are the arguments, the second argument. Okay, argument list. So the first argument over here. Okay, the first argument in the second argument of the printf function is going to be, remember, Celsius temperature is going to be Celsius temperature over here. So Celsius temperature is going to replace, the first print %f, and I'm going to put another comma, which is going to be the second argument. Okay, it's going to be the second it's going to be the second argument that I'm going to pass, okay, in the second argument of the printf function. Okay, the printf method. I know what it can be confusing, but basically the printf method takes two arguments. The first is the format specifier. The second is the argument or argument list. Now, each percentage F or percentage D or percentage S, whatever you put here. Okay, each argument you pass replaces these format specifiers respectively. So the first percentage F, Celsius temperature is going to replace the first percentage F, and what I type next, which will be the Fahrenheit temperature, I'm going to copy it, will replace the second percentage F. So it replaces the format specifiers. It replaces the placeholders or the format specifiers respectively. So Celsius temperature is going to go here, and Fahrenheit temperature is going to go here. All right. So now we've said we want to display Celsius temperature as just a float. We haven't added any more as just a float. We haven't added any more format specifiers. Okay, or how we want it formatted, or any flags or anything just to make it or just to format it in a specific way. So from Fahrenheit temperature, also we've also said that we want to display that as a float. So that's why we put in percentage F. So I'm going to go ahead and terminate this line, and let's see how it runs so far. So we're going to have a header, and each time the loop runs, we're going to calculate the Fahrenheit temperature, display the Fahrenheit temperature right under the header. It's going to display the Celsius temperature and the Fahrenheit temperature, all formatted as floats. Okay, so let's see how it runs. I'm going to go ahead and compile this and create a new folder for Fahrenheit table. And save it here. Okay, so I'm going to run it. And oops. All right, let's see. Let's see what happened. Okay, so what happened was we displayed it all right, but we didn't create. We displayed it all right. So this is the first. Celsius temperature. The next one is Fahrenheit temperature, but we didn't create a new line so that this displays a new line. So it's basically displaying it horizontally instead of vertically. So after we've displayed the second, after we've displayed, let's say, Celsius temperature and Fahrenheit temperature, let's go ahead and create a new line to break whatever comes after that. Okay, so that whatever comes after those, like the Celsius temperature and then the Fahrenheit temperature, whatever comes after that will be displayed on the next line. Okay, so let's try this again and run it. Okay, so let's see what's happening. Okay, so let's try more tabs and see how it displays. I'm going to put 3 or even 4 more tabs and compile this and run it. See what happens. Okay, so what is happening is over here, trying to fix this. Okay, so let's see. I'm just trying to figure out why this is off and everything else is okay. So probably is you have percentage F here. New line. Let's see. Just bear with me here. I'm trying to figure out why this is just displaying like that. Okay, went too much. So we're going to calculate the Fahrenheit temperature. We are going to put a tab in between It's probably because of the numbers. It's probably because of the numbers. I'm trying to figure out exactly what is the problem, and I can't I can't see it. But basically, we can play around. What we are most interested in is the numbers. But I want to fix this this space. I don't know why all of a sudden this is now stretching. I don't know if it's because of the fact that this is of this extra 0. I don't know, but it could be. But it shouldn't even do that. So percentage F, 3 tabs, another percentage F, and a new line character. And it's still doing the same thing. Hold on. This doesn't necessarily matter. What we are interested in is the numbers, but I want to fix it so that it looks nice. I think I'm still missing something. If I remove all these tabs, and okay, it's looking close, but it looks to me like it's just this. It's just because from number 10. From number 10 gives. You know what? Let me go ahead and let's format it and see how it looks like. So right now it looks like this. If I put one tab in between them, it looks like this. See, that's the first 10 is not using a tab, but remember the last ones are using a tab, and that's what boggles me. It's probably something very simple I'm not seeing. System.out.printf. Okay, so let's go ahead and format it. It could be because of this. Let me see. It could be because of these zeros. I don't know why all of a sudden this is only taking like a space, and this is taking the full tab. So we are starting from 0. There's an equal to this. All right, let's move on. I'm sure we'll figure it out. But what I want to do is actually format it. Okay, so sorry about the delay. I just wanted to figure it out, but I can't see it for any reason. Maybe I have to go through it some more. But let's go ahead and format this, because now we are starting from 0 and displaying the Fahrenheit temperature equivalent. All right, so let's go ahead and put more tabs here, just so it matches with this Fahrenheit temperature. Oops. And I was way over. Delete a couple tabs. Okay, we'll work with this for now. Oh, I think I know what it is. It's from this header. So let's see, Celsius temperature with a tab and Fahrenheit temperature. Okay, and then the next line, I'm underlining this, and probably need a couple more tabs here. Okay, now that didn't really do anything. That's just for underlining the Fahrenheit temperature. Okay. All right, so we'll fix this. All right, so let's go ahead and format it. For now, it's formatting with lots of zeros after decimal. So let's go ahead and round it to a certain number of decimal places. So let's see, and these numbers are also not correct. So, but we'll fix that. We'll fix that in a moment. So first, let's go ahead and round it, or better still, let's go ahead and solve this. Fix this first, the calculation first, and then we'll move on to round it so that we can see the numbers after the decimal point, and then later on we'll round it. So 9 divided, anytime you so 9 is an integer. Okay, so basically this formula is correct, but the thing is we have to add some more detail so that Java can understand really what this formula is. Okay, so we can get the right value for Fahrenheit temperature. Anytime anytime you divide an integer by an integer, Java refers to the whole thing as an integer division. So even though, for example, I'm just showing an example here. So I'm going to pull up a calculator to illustrate. So if you put 9 divided by 5 in the calculator, you're getting 1.8, right? But the thing is, instead of Java evaluating this as 1.8, because this is an integer, this 9 is an integer, and 5 is an integer, Java reads this as, or sees this evaluation as an integer division. And what it does with it, the integer division is this. Even though 9 divided by 5 gives you 1.8, because both of them are integers, and because it sees that as an integer division, it's going to return only the first integer it sees, or only the integer it sees, and anything after the decimal point, it doesn't return it. It just throws it away, or it will slash the whole thing off. So instead of returning 1.8, instead of this 9 divided by 5 evaluating to 1.8, Java is going to see this as an integer division and evaluates this to be only 1. So in order to really evaluate this to get 1.8, or to get a decimal, if indeed it's a decimal, well, in this case it is a decimal, it's 1.8. In order to do that, one of these operands have to be a double. But the thing is, 9 is an integer, 5 is an integer. One way you can do that, you can simply just do that by saying 9.0. But we want to keep it, the same according to the question. We want to keep it looking like what the question is. One way we can do that is by using typecasting. Typecasting is by basically converting one of the values to a double. Okay. So what I'm going to do is it can be any of them. It can be either 9 or 5. At least one of them has to be a double. At least one of them. If both of them are doubles, that's fine. But at least one of them has to be a double. So I'm going to go ahead and convert this 9 to a double by using typecasting. I'm going to type in the word double in front of it, surrounded by parentheses. So surrounded with parentheses. Not the 9, but the word double, or the type double, surrounded with parentheses in front of what you want to convert to a double. So now when I compile this and I run it, this and Fahrenheit temperature is also a double, so it should store the right amount. So if I run this now we are getting correct values. Now we are getting now we are getting the correct values. The other one was giving us just 32, 33, 35, and we weren't getting the values after the decimal point. So now I wanted to go ahead and round it. So the first percentage F is Celsius temperature, which is this, right? So we have so many zeros after the decimal point. So the way to round it is in the format specified of the Celsius temperature. In between it, I'm going to type in 0.1. Okay, I want to round it to 1 decimal place. Now 0.1 is like the precision. I'm going to type it in between the percentage and then the F. So 0.1 is basically going to round Celsius temperature to 1 decimal place. I'm going to do the same thing for Fahrenheit temperature. I'm going to round it off to 1 decimal place and compile this and run it and see what happens. Okay, so now our problem is also fixed. I spent about like 5 minutes trying to figure out how what's wrong with that. I think what was wrong is, so let me take it back. I mean, let me know round it now. And I think it was because of the fact that maybe this extra 0 pushed this all the way to the right. I don't know what's happening here. I really don't know, but it looked like it was being pushed off. The code looked fine, so I was trying to figure out what was wrong, and I couldn't find it. So it looked like that's for some reason. I don't know. I don't know. Maybe it's still with the code, but as far as I'm concerned, it looks fine. But rounding the Celsius temperature and the Fahrenheit temperature to 1 decimal place fixed it. Kind of fixed it, at least. So now at least we can view it in a very nice manner. So when I compile this and I run it, now we are rounding off both of them to 1 decimal place, and we're getting the correct results. If these results are not right, you just go ahead and recheck the formula. But it looks fine to me. It looks fine to me. So I'm just all the rest that's left is just to format this. I can just put a tab on the left of these values so it just displays in the center. Extend this to, I'm just trying to do that. Create some more lines here. And a couple more here, maybe like 2 or 3. Put a tab right before the first percentage F. So a tab / T, and that's going to force this also to the right a little bit. So I'm going to compile it and run it, and it's kind of you're getting let's see. Now you can do this by yourself. I'm going to delete one more of the tab here just to push that to the left, and it's kind of I think it should look a little bit better. Getting close. The only thing I need to do is delete one more tab here. Okay, now this looks kind of reasonable. But all this stuff is not really. You can do the design do the design later on. But what's important is actually the values. So we are starting from 0 and calculating the Fahrenheit equivalent of the temperature, starting from 0 using a loop all the way to 20 and calculating the Fahrenheit temperature equivalent. So that's it. Sorry if I took too much time trying to fix that formatting error. The values being pushed, half of the values being pushed to the right. I was trying to figure it out, but I couldn't find it. But when we I think it was because of the numbers being bigger. When we formatted it, it fixed it. Again, I couldn't find the problem in the code because the code looked fine to me. But we've at least we've fixed it now. At least we can view this in a very nice way. So yeah, if you have any questions, please comment down below and I'll do everything to respond to them. Thank you very much for watching. Take care of yourselves. Have a great day. Have a great night. Have a great sleep. Have a nice time. Take care of yourselves again. And I'll see you next time with the next program. Bye-bye.